Hello and welcome back. Today, since it's August 8th, I'll be doing day 8 of Advent of Code. Yes, I know I skipped the previous 3 days, but you know, day 5, day 6, I was out the entire day, and day 7, I slept the entire day, so I had to work today, so I couldn't catch up. And now that it's after work, I can start doing it again. Remember, I'm emulating what I would be doing in December. So maybe in December I'd be going out all day too. Maybe going out with friends that come back for the holidays, etc. And I wouldn't be able to do it. So with that in mind, let's just get started. I hope they would not depend on previous days, but we never know. Then we have to actually switch it up a bit. All right. Day 8, 7-segment search. Oh, it looks more and more complicated after you switch a couple days. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays, okay, I know what these are, in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'll better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the 7 segments named A through G. Yes, that is very obvious. That's how 7-segment display works. 1, 2, 3, 4, 5, 6, 7. And usually they be in some kind of binary number. So to render a 1, only segments C and F would be turned on. The rest would be off. To render 7, only segments 1, 2, 3, A, C, and F, I believe, without looking. Yeah, A, C, and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All the digits within the display use the same connections though. So, you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1. So that means segments C and F are meant to be on. With just that information, you still can't tell which wire B and G goes to which segment, correct? For that, you'll need to collect more information. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see. And then write down a single 4-digit output value, which is your puzzle input. What? Oh, you solve this on your own, and then you use this. You get the 4-digit output, which is your puzzle input, and then you use that to solve something else. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. The entry is wrapped here to 2 lines so it fits. In your notes, it will be all on a single line. Each entry consists of 10 unique signal patterns, a delimiter, and finally the 4-digit output value. This is on the right to the delimiter. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the correct wire segment connections. Because 7 is the only digit that uses 3 segments, dabbing the above example means that to render 7 signals lines, D, A, and B are on. Because 4 is the only digit that uses 4 segments, E, A, F, B means that to render 4 signal lines E, A, F, and B are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. Oh, okay, I get it. This is still an actual number though, these 5 segments. Wait, what? So these would be 5 segment numbers, like 2, 3, 4, 5, 5, 9. No, 9 is 6 segments. 3 is 5 segments, 2 is 5 segments of 5. So this is either 2, 5, or 9? Or are these not actually numbers? They could just be a random configuration. I don't understand this. Okay, unique signal patterns are digits. This is just a random configuration of segments. Which is just an output value. Okay, it doesn't have to be a number. Okay, gotcha. These are all numbers. Okay. I don't understand how this is a coding problem though. This is just something you figure out like a math logic puzzle. For now, focus on the easy digits. Consider this large example. Because the digits 1, 4, 7, and 8 use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after the delimiter on each line. In the above example, there are 26 instances of digits that use a unique number of segments highlighted above. In the output values, how many times do digits 1, 4, 7, or 8 appear? What the hell is this, man? I don't understand. Can you explain this better? Okay, let me see what the puzzle input is. Oh my god, what is this? Okay, this is where we need to use code. What? What are you even supposed to do here? Oh, this is going to take me hours, huh? Because I don't understand the question. Okay, CB is 1, but why is GC also 1? And CG also. I don't understand. Oh wait, those are letters. Hold on. Numbers are before the delimiter. GF, B. Hello? Does each line have to be different? Okay, let's look at the example at least. Each entry contains 10 unique signal patterns. Yes, the same connections are used, but we don't know what they actually are. How many times do the digits 1, 4, 7, or 8 appear? What? Output values? But they're not even the same. Oh, they are the same. Hold on. CG is 1. CG is also 1. Man. I guess they're holding our hands. We don't actually have to do any of this logic here. So in the output values, there'd be 1, 4, 6, 1, 4, 7, 8, but would they be the same? And they have unique segment lengths. For example, 1 is the only one with a length of 2. 4 is the only one with a 1, 2, 3, 4 with a length of 4. 7 is the only one with a length of 3. And 8 is the only one with a length of 7. So we should know which ones they are, but I'm just wondering in the puzzle input, for example, here in this line, there's CG, CG, CG. Okay, that's obviously 1 in the output. But what if, is it possible that, the output could be CG and the input could be PE? That's something to think about. For example, yeah, right here, BG and GB. GB. Okay. This is how I interpret a question then. Is that the input can only be digits. The output does not necessarily have to be digits, but they could be digits. So therefore, we actually have to compare the input and the output. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all 10 digits are displayed, are written in the input. But the output could be anything. It could be a letter, it could be something that doesn't make sense, it could be a digit. And the question makes it easier by only letting us solve 1, 4, 7, and 8, which have unique lengths. Okay, so let's just get started then. Wow, day 4. Days passed by so quick, man. Let me open this up. Day 8 sample dot text. And we will copy and paste this. This is so annoying. you made it 2 lines for no reason. When it should be 1 line. Day8.python. This was copied the day 4 stuff here. Gonna need a day 8 sample, day 8.txt. Initial delimiter is going to be a single new line, which we have. So first off, iterate through the entire input list. And what should I call this variable? Entry. Okay, for entry in input list, so the way I want to complete this is each line is an entry. The lengths of 1, 4, 7, and 8 are unique, corresponding to 1, 4, 3, and 7, respectively. So I would split that line by the delimiter. The left side, I search for all these lengths, store those into a temporary variable, and then compare the exact same characters, exact same strings with the entries on the right. And if they match, then I add 1 to the count, because we don't care about anything else but the number of times do all these 4 digits appear. Do it for the entire input, and we get our answer. So let's do this. So would I call this input or output? What digit list? Input list dot split. I'm going to split it by a space, a vertical, and another space. And that should be good enough. Take the first element and then split it again by the space. Output list, we just take the second element after splitting. Obviously here I have some repeated code because I actually split the same thing twice, but it should be fine. It's going to be very, very negligible that then that saves me from thinking of a variable name, etc. Have a count. And since we don't care about, we don't need to match the numbers exactly. We just have to know if any of the digits 1, 4, 7, and 8 exist. We can actually just use a set. We don't have to use a list for this. And this can't be a variable. 1, 4, 7, 8. Just instantiate a new set. Oh, what? For each pattern in the digit list, if pattern.length is 1, 4, 7, or 8. Okay, it's in this set. We add that pattern into the 1, 4, 7, 8. Okay. And then we go through the output list. And if it's if it exactly matches with something in the input list, then we add one to the count, and that's it. Should be entry, split the entry, don't split the input list. And in the end, we can return count. And that should be it, honestly. Start the count. You go through each entry, you split it by the delimiter, and then you split it again by the spacing. And there's no additional spacing at the end, so I don't have to trim it or anything. So this should work. Take the first entry after you split it, which is this, and then split it again to get the array, to get the list. Take the first element of the split, take the second element of the split and split it again Look at the output list. So there shouldn't be any, this length check should work because you're splitting it correctly. Okay, let's just run it. What the heck did I do here? Zero. Does that look right? No. I wonder if I can split it by this multiple delimiter here. Let's go through the debugger. Why not? Okay, digital list is correct. You can split it like that. Output list is also correct. Unique values. That should be it. Should also be it. 3 is should be it too. Unique values 1478. The problem is we're comparing the length of the pattern with these. We don't want to do that. Should actually be unique lengths. The length of 1 is actually 2. The length of 4 is 4. The length of 7 is 3. The length of 8 is also 7. So now if we run it, we'll get a total of 7. This is problem is so out of it. We don't care about. Why is CBG unique when it's GCB? I guess that makes a bit sense. FDGACB. FDGACB. Okay. From the sample example, it looks like that the output are also numbers. It's not any random character, which is incredibly not clear from the puzzle itself. But they could be combinations of letters, not exactly has to be the correct permutation. For example, GBDFCAE exists, but GBDFCA is also there. So you can actually make this easier on yourself. We don't have to store all this into a set. You can actually just look at the output because it will be the same as the input. Only with a different combination possibly. For example, CBG, there would never be an input with ECB, which does make it. I'm making a lot of assumptions with the puzzle input because it's not clear at all. But even for the bigger ones, for example, GB, it's GBG. It's just a different combination. AEBG, EABG. So we actually don't need to remember this. We just go through the puzzle output and count it up. Gosh, that was confusing. And we get 26, which is correct. Wow. Is there extra space at the end? I hope there isn't. So let's go day 8. Yep, there are no extra spaces. Everything is correct. And so the sample, let's do the actual text. And hold on, we don't need this. 383. That's the right answer. So I made the correct assumptions about the puzzle input, which is why I got the correct answer. I can go to part 2 now, which should be much more difficult because you might need to figure out each individual letter or each individual digit. Part 2. Through a little deduction, you should be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configurations. So the unique signal patterns will correspond to the following digits. Then the 4 digits of the output value can be decoded. Therefore, the output value for this entry is 5353. Following the same process for each entry in the second larger example above, the output value of each entry can be determined. Adding all of the output values in this larger example produces, for each entry, determine all of the wire segment connections to decode the 4-digit output values. What do you get if you add all of the output values? Okay, so here we actually have to figure out each of the digits. Well, it's pretty obvious what 1, 7, 4, and 8 are. How do we do this though? It seems like some mathematical equation where we have a couple of it's like algebra. We have a couple of variables and you just figure it out. So we know what 1 is, we know what 7 is. We know we can automatically deduce what is the topmost segment. And then the rest we can know. 8, hold on. 1, 4, 4 uses the middle, 8 uses the middle. Alright, go back here. we automatically know what this letter segment is. With that, what can we deduce? Well, 2 and 3 is something I noticed. Or just anything. 2 or 5, for example. 2 would have C but not F, so we know that C is the top one and F is the bottom one. I mean, okay, there's way too many. It's very easy to figure this out. But just to convert that into code, how do we convert math into code? How do I convert algebra into this? Do I even want this? Multi-line comment? Single comment. Yeah, why not? Multi-line comment. So we can figure out the top segment from 1 and 7. I just want to look at what is easiest to solve. I noticed the difference between 2 and 3, but we don't know which one is 2 and 3, so we can only look at one. Oh shoot, what did I do? 4. 4, B, and D could be interchangeable. 8 has both B and D, which is useless. Hmm. Four, we know what B and D are. Ah, so we already know what 1, 4, all the rest have D's. Except for 0, so we can actually figure this out. Looking at the remaining digits. Okay, we got this. The remaining digits all have one segment in common, except for 0. Find it. It might not be the easiest to do in code though, but we can still do it. Find 0. We now know the middle segment and the top left segment. Zero has a length of 1, 2, 3, 4, 5, 6. What else? What other ones have 6? 2, 3, 4, 5, 6. 4, 5, 6. I mean, that remaining length 6s the 1 segments exist, it is 9. If both 1 segments exist, it is 9. Only one segment exists, it is 6. But I feel like knowing the segment actually doesn't help. Left segment, top left segment, top right segment. So we're missing 2, 3, and 5. Oh, this might be difficult. Look at the remaining digits. If both segments exist, it is 3. look at the remaining digits if it can entirely fit in 6. It is 5. The remaining one is 2. My gosh, this is my algorithm. My math is so much easier to just figure this out in your head, actually. But I'm not going to figure it out in my head with such a large puzzle input, obviously. So I think this should work. With that, we can actually figure out all the digits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the question is, how should I store it? My hunch is to store it with the letters, with the segments, in a dictionary as the key, and the corresponding number as the value. That way we can search the output and then we figure out what it is. How this actually works, I don't know, but let's just start coding and figure out from there. So same thing, we don't need any count. Here's a unique length. Do we need that anymore? We might need more than one dictionary length to who cares? I don't need length to whatever we need. Digit list. And output list too. All right. Go through the pattern digit list. We don't need this unique length set anymore. Let's just do pattern to digit map. So here we actually have to go through every single case because they correspond to a different number. Actually needs to be here. Sum. Oh, no. We need the pattern as a key. The value is 1. Okay. Pattern's a key value is, no, it's not 4, it's 7. Now 4 is the digit, and then 8 is the digit. Okay, we have 4 digits solved. Because I have no foresight, I'm just going to make a digit2 pattern map because I think we might need to use it. The other way, just to figure out all the other digits. Eight. And now we can actually just remove the values that we don't need. In the digit list. Okay. So what was my algorithm again? Remaining digits all have one segment in common except for 0, find 0. I wonder if there's an easier way to do this with set. You can also just check if they're length 6, 2, 3, 4, 5, 6. Can we check the common ones? No, because we don't know which one is the middle segment here. That is a tricky one. You actually have to compare with 2, 3, and 5. Because 2 and 3 have C's. 0 has C's, but 5 doesn't have C's. So 5 and 6 don't have C's. There's at least 2 that don't have C's, but there's only 1 that doesn't have D's. So I'm actually just going to iterate through the rest. Count them all, and then see which one has the highest count. And whichever of the remaining does not have that letter is 0. Don't know if that's the best way to do it. Like if this algorithm is the most efficient, but it's the first one I thought of, so I'll just go with it. It's probably an easier way to solve this. Should I use a dictionary, or do I really not need to? I think I need to. You can't really use variables with segment letter names. Convert variables into strings. Or yes, you can. Let's just go like this. Okay, all of these are zeros. Actually, this is too many if statements. I should just use the dictionary. And I can actually just initialize it to 0. And G is 0. So go through each pattern, and then we go through each segment in pattern. Counts, segment plus equals 1. Very easy. After we're all done, most common segment equals max segment counts. And then we have to go through it again. If the most common segment does not exist in that pattern, we know that it's 0. It's quite difficult, huh? Should be easier from now on. Look at the remaining length 6s. Remove pattern, we just remove it from there and then break it. Look at the remaining length 6s. If length of the pattern equals to 6, then we'll go through the 1 segment. The pattern map. Segment in addition to pattern map 1 If segment is in the pattern, I don't even have to go 4. Hold on. Segment 1 equals the first segment. And then segment 2 equals the second segment. If both segments are in the pattern, then that has to be a 9. I don't want to do an else statement, but I think I should, because theoretically it should work. That being that if only one segment exists, then it should be a 6. But we don't know. But what if something goes wrong in another portion of the code and then both segments don't exist? Then it gets a bit tricky. But we will bank on that not happening. After that, we're going to remove this and that. So we're stuck with 3 left. Look at the remaining digits. Don't need the length anymore because we know the length is 5. Both exist. It is a 3. And we can remove the 3. Oh, we can just remove the pattern here. Break. And let's go through it again. For a segment in pattern, can fit in 6, right? I wonder if there's a contains function in Python just to make it different, just to make it easier. I would doubt it though. Hold on. This is Python 3? What? Does it look so unPythonic? I guess let me try to use this. I don't even know if this will work. Otherwise I have to use regex. Oh, this is a function. Oops, that's not what I want. If it contains, then it is a 5. 2 cannot fit in 6, right? Then it is a 2. Does that make sense? Alright, now that we have our dictionary filled out, we can actually go to the output list. And sort it, maybe? Because it might be out of order. Okay, combination, I'm looking for the math combination. I wonder if there's an easier way to do that, or I have to figure it out myself. Sorting seems to be the easiest way. You know, I just thought of something. Do we actually need to do all of this? What if we just find the segments? Holy cow. If we find the segments and know what are the key segments, then we can actually just figure it out. So we go by length. Length 6. You know, if it has D, if it doesn't have D, it's 0. If it has C, then it's 9. If it doesn't have E, it's 9. If it doesn't have D, it's 0. If it doesn't have if it has both D and E, then it is 6. Oh my god. And then for the 1, 2, 3. For the 5 lengthers, if it has both C and F, it's 3. If it has both B and F, it's 5. And if it has both C and E, it's 2. Why do I even need to go through all this? And we already know what 1, 4, 7, 8 is. Wait. This is so much easier. What is all this crap? We can only figure out actually you've done it and figure out what is the best way to do it. Anyways, I want to know if this actually works first. Probably doesn't even work. One 8470. Okay, that's correct. Why are there 3 length 6s? The 0 is not correct. Really? D and F have both 6? Oh, I missed this. D and F are all maximums. Oh. I actually can't do it like this, huh? Man, that's honestly very sad. I have to figure out another way to do this. So look at the length 6s. I have CF. If one is, both segments are not in it, then it's 6. It's very quick. Ah, this should be easier. Look at the length 6 is. We already know what 1 and 4 is. If 1 exists, if 1 does not exist, then it's 6. And if 4 exists, then it's 9. And the remaining is 0. Okay. I think this is a much cleaner way of doing it than counting everything. Holy cow, what is this? Oops. Just see what this contains. If length of the pattern is 6, if the pattern contains one, then we know that it is if it doesn't contain 1, then we know that it is 6. If it contains 4, then we know that it's 9. Because 6 does not contain 4, 9 contains 4, 0 does not contain 4. And now we can have the else. I'll remove six, 9, and 0. I actually can keep this even though it's not ideal. then here we can check if contains 1 B3, else if contains 6, it's 5, and it's 2. Maybe this will work. Here 9. Why though? Why? It's because we don't need this anymore. Why though? That's correct. There should be 3 more. Pattern does not contain 1. No. Contains needs to be in order. That's very annoying. I guess I have to use regex here. I knew it had something to do with sets here. And there's no duplicate, so it doesn't matter. They are subsets. Oh, his the other way around. Is subset of that. Seven. 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I mean, I guess I don't need to. If I'm doing it by this method, which is much more cleaner, then I don't need to figure out what position the hexes go in. GCF? 3 should have 7 in it, yes. AB. 2. That's correct. How do I figure this out? I did not order from Burger King. What is this? Seems like a legit link. I don't know what happened there. Anyways, we're still only half done, but the second half should be much more easier. For pattern in output list, if the pattern let's just sort everything in the pattern to digit map first. Or even better, we should just sort it when we're putting it in. because we're not using it anywhere else. 6, 7, 8, 9. Sorted pattern. Find that value inside this dictionary. Number string equals this. Convert into string first. Oh, this is so annoying. At the end, add the number string. And then we can return the sum. Should work. Too tired for anything else. What in the world is unhashable? Oh, did I screw this up? One sec. Sorter returns a list. That's annoying. I want it just to be a string. Like, do I have to do this? Oh, shoot. That isn't that just how I did it? Sorted plus join. Oh, it's that. Oh, I got the annotation wrong. This is what we need. So just sort it right there. Do the same over here. Should work. Now for some reason X is not in list. Because it's sorted. Yeah, that should work. Six one one two nine. Wait, 61129 or 61229? Oh, and all the values. Okay, that works. That actually made it much simpler too. Now let's just try the actual input. No, what happened here? Wait, is this something from the instructions that I don't understand? It should work. A, B, C, D, E, F, G. A, B, C, D, F, G. What? So there's A, C, D, A, B, C, D, F, G. A, B, C, D, F, G. Why is it not working? A, C, D, B, F, G, correct. A, C, D, B, F, G, that's correct. So that should be A, B, C, D, F, G. Which apparently does not exist. A, C, D, B, F, G. A, C, D, B, F, G. That actually, that exists. A, C, D, B, F. So there's a bug in here somewhere where it's producing A, B, C, D, F, G. And that's correct. A, B, C, D, E, F. A, B, C, D, F, G. A, B, C, A, B, C, D, E, F exists. What about F, B, A, C, G, D? Why is this not sorted correctly? A, B, C, D, F, G. A, B, C, D, F, G. A, B, C, D, F, G. Did I just forget to sort one? Everything else is sorted but 0 actually. Yeah, I just forgot to sort. Good grief. No, 98900. I have no clue if this number is correct. Oh, looks like that's the right answer, and I'm finished with this problem. Okay, I want to think a bit, even though I've been thinking for a couple hours. Doing some weird algorithmic solution, is that the way to go, or is there an easier way? Because really before it was pretty messy, but it is at least cleaner now. I have to use 2 dictionaries, which is, I don't know if it's ideal or not. Let me go back to this question. Like, and then I have to do some, you have to sort it, and then string concatenation because it's out of order. And then over here, convert it to a string, then back to an int again. What would have been a cleaner way to do this? So I haven't tried counting by hexes. If I find out all the hexes, then I know what they all will be. But then they'd still not be in the right order, and then you still have to sort it, so it's not so simple either. And in order to find all the hexes, I probably have to do something similar. Yeah, I don't know. How did other people do it? Maybe I just look at their answers. Should be day 8. I want to watch some other guy's YouTube video. It's all on GitHub. What do you have here? Find 1478, find 6 and 3, find 9 and 0. Oh my god, that's something similar to what I did. I don't think... Yeah, looks like everyone sort of has the same kind of solution. There is really no easy way around this, huh? Oh, so Python does have that itertools library, and that's how there'd be some kind of permutations function, but I don't really know them unless I read the documentation. I just decided not to use it. I want to see one some of the experience guys. The 1,000 more replies. How do I get the first guy? Yeah, this is basically everyone's algorithm. Just you have to do some math with this. There's just no way around it. And it's archived. Can't even figure this out. Alright, bro. What is this? Using digits with known lengths as masks. This is probably the most cleanest solution. I don't know if it's necessarily the easiest to read. What in the world is a match? Which wires which? I think that's just a smart solution just to figure out which wires are which. It's very logical instead of trying to figure out some kind of clever solution here. But it's interesting to know what could be accomplished. I want to see this diagram here. Okay, contains 7 else. I mean, that's sort of how I did it. This is so unreadable. What is this? Yeah, anyways, there looks like there is a more clever solution than what I did. So I'll just look more into this. But for now, this is actually a good way because of a good logical way to solve it. Anyways, I'm done with today's Advent of Code. See you all next time.